Hello, everyone. Welcome again to this conference, and in particular to this talk about test your test. And perhaps the titles sounds funny for you because, test your test. And uh, let me introduce me first, and after that, I will explain what this means about test your test. My name is Andres Sacco. I work as developers since 2007 using different languages. Most of them are connected with the JVM like Kotlin, Scala, Java. I also use another languages like PHP, NodeJs, Haskell, and other some kind of external languages. I participate as technical reviewer on some of the biggest editorial around the world. So the editorial send me a manuscript, a chapter, or the entire book, and I need to read it, analyze if everything makes sense or not, and send my corrections. I also write some books, courses, and theoretical practical scenarios. Some of them appear on the presentation. There are a lot of another ones, but it's just the most relevant. And I participate as speaker on different conferences. You have my contact information on the presentation, my LinkedIn, my email, and my GitHub. So if you have any doubts, any question after this presentation, please contact me by LinkedIn and send me an email. I will try to help you as soon as possible. So we are developers, or most of them are developers or QAs. And when we need to create a new feature or introduce a bug fixing, which is the flow of the things. First one, you create a new branch and you develop your feature or your bug fixing and you create everything. And at some point, you create the test. And your test have an 85% of coverage, which is great for us. And after that, you create a pull request or merge request and give to another person or a series of people to check if everything in your source code and in your test, it's okay. Everything is okay, so go to production. And when you go to production, the problem appears. And you can think, why this happened to me? I create everything. I create my unit test, and my unit test have a good code coverage, and someone checked that everything that I created makes sense. So it's possible that this happen on production. Yes, it's possible. And why this happened? Because when this kind of problem appear on production, the developers have different kind of excuses. Well, Sonar now showed me a problem. So for me, the code, it's okay. Nothing happened to me. Perhaps it's something related with the server or my cloud provider. It's not connected with my source code. The second one is like, oh, I have too many years of experience. Come on, man. This is impossible. The problem is related with the infrastructure. It's not connected with my source code. Other excuse, I create a huge number of tests. I develop a new feature and I put more or less 100 tests for a particular method. It's impossible that I miss something. The last one, you think in one particular language or framework is like, no, yes, I use JUnit or I use, I don't know, Spock or something like that. And this framework, this library cover all the things to me. It's impossible that something bad happened. These are some of the excuses. Perhaps in your case, you listening another kind of excuses when this kind of situation happen. Let's show you an example of my idea. Look this example. Pay attention in the last line, not pay attention in the invocation of a method. First one, I forgot to mention one. This is a unit test or using Java and JUnit. And the last sentence is the assertion of the test. If you see, the only thing that I check if the object that I obtain when I invoke a method is only not null. And the first question is why you don't check the attributes or the values inside of the object? Why only you check if the object is not null? Here you have a problem. Well, and the excuses is, well, my code coverage say that everything looks fine because I create this unit test and my code coverage or Sonar say, yeah, everything's okay. And when the problems appear, the possible answer is, oh, yeah, well, perhaps I forgot some validations. Well, we create different type of tests. Unit tests to cover some specific logic or some specific branch inside of your source code, an if-else condition, a for, a while. This is more a detailed type of test. After that, you have the integration test. And after that, you have the functional test. And the last type of test is the end-to-end testing. So when you move from the unit test to integration test, you lose a lot of things. You gain or you earn different things like, okay, I put the focus in another part of my application. I need to check if everything works fine and how interact. But I miss the level of detail. So it's not possible to think, oh, I will create 10 different integration tests because I need to cover if condition, an else condition, a while condition. So it's impossible. So if something bad happened on your unit test or your unit test had problems, you in some way you affect the entire pyramid. Well, a new concept appeared related with the type of testing, mutation. Oh, this is a new kind of test. I need to write a new and tons of tests. I need to do a lot of things. No. The idea of mutation test is the opposite. The idea is validate your test. The idea is validate if your tests are effective or not. And what is the main difference between coverage and effective? Because if I have a good code coverage, what is the idea of the effectiveness? The idea is that check if your test have all the validations. So if you introduce some modifications in one particular feature or one particular method or class, what happened with your test? Your test fail or pass. In the case that I show you, if I change something inside the object, the country, DTO, if I change something, this test is not effective because I don't put the assertions that check if everything continue working or not. So you have a problem. And here is the most important part. You don't need to create new tests. You will reuse the test that you created and create some kind of things like changing on your source code, introduce mutation, modify your source code in some way, and check what happened with your unit test. This is the main idea of the mutation. So how this process works behind the scenes, because this look great, but behind the scenes things happen. So first one, mutation takes your source code and introduce modification. Each modification is a mutation. Modification like what? Imagine that you have a condition like check if an attribute is null or not, and what happens if I change the condition? Instead to say, okay, if this object is null, do these things. What happens if I say, if the object is not null, I change the condition? This is a modification. This is like a mutation. After that, you execute the test using the original source code and the code with the modification. So your test, you not suffer any kind of modification. You modify only the source code and execute the test with the original source code and which with each mutation, with each variant of the source code. And after that, you compare the results. What happened with my test, my original with my original source code, working or not? Work, great. What happened with my test with the mutated source code? And here is a concept that is so difficult to understand. If your test work in a common scenario, you have a green in your test, everything looks fine, great. Red, bad, something in your test failed. And in the mutation test, it's the opposite. If your test failed with the modification, your tests are effective, which is great. If your test passed with the modification on the source code, something in your test is bad, is not effective, this test. And what type of mutation exists? Well, the first one is the decision. Introduce little modification in the conditions. Change an and for an or vice versa. You can invert conditions like greater than to less than, and vice versa. Here are some examples. Look the if condition and what happened with the mutation. Here is the one example. What happened with the source code? Another kind of mutation is the statement. So in this case, you duplicate the code or move the lines. Imagine that you have a method that the first line of the method check or introduce some kind of validation about the parameters that receive. And in the case that some parameter is not informed, throw an exception. What happens if I move this validation at the end of the method? What happens if I duplicate the code? What happens if I change the order? Or what happens if I remove the validation? How the method continue working? Here an example. I remove an the if condition. And so the next line after obtain the information is throw an exception. Or instead to do the validation, I return the result. Or I remove all the source code inside of the validation. So these are mutation variants of the same example that I showed you at the beginning. The next one is the value mutation. And what this imply that, for example, you initialize a variable with a specific value. For example, with an integer value with 0. An integer. What happens if I change the value to 100 or -1? What happened with this? And what happens if I execute the test many times? This source code will be affected in some way. So imagine that I execute this many times and I change some condition, the test continue working or fail. Okay, why I need to use this? Why is so important? I mean, okay, I reduce the risk, but the idea is to improve the skills of your developers, because if you know that your test is not effective, you understand the risk of deploy this on production. So the next time that you will create a unit test, you put attention on some little details. Okay, I will introduce or I will add more assert on my unit test. The next one, of course, increase the quality, because if you create a good test, you will discover different problems that you missed during the creation process or when you develop the new feature. Reduce the risk that something bad happen on production, like us at the beginning of this presentation, and reduce the time of manual revision, because the people who are responsible to check your source code need to check if your test makes sense or not, and if you check all the conditions. What happens if I introduce the mutation test? It's only I delegate to mutation test to check if the tests are effective or not, you have two different metrics: the code coverage and the effectiveness of your test. So you have a good code coverage, 90%, for example, but your effectiveness is 20%. Okay, you don't have a good unit test. Which are the problems of this? Oh, because everything looks fine, but this need to have some kind of problem. Well, consume a lot of resources and the time. Imagine that you need to create many mutation of one specific method, and for each mutation you need to run your unit test. So imagine that you create 20 mutations for one specific method. You need to execute 20 times your unit test. This implies memory, use the CPU, many problems. And the developers need to know which things need to test. You of course, you can use mutation tests for all your tests, but in some cases, there are some kind of pieces of your application that is not necessary to check. And this is one of the most important part, is you can use it on external libraries, because this works as a black box test. Only can modify the things related with your source code. If you introduce an external library, an external dependency, you can do the modifications. You can test this. And a lot of mutations produce that you spend too much time to verify all the things. So at some point you need to reduce the scope of things to check. Okay, great. The concept of mutation tests makes sense, but how many languages support this mutation test? Well, Scala, Java, and Kotlin have support using a specific library. And in the other side, there is C# and JavaScript. Pitest have support for Scala, Java, and Kotlin. So in the case that you have a project on Java, and for some reason you decide, okay, we want to move to use Kotlin, but we configure a lot of things on Pitest, you can take the configuration and put on the Kotlin project without any kind of problem. In the case of JavaScript or C#, which use Striker, you have a problem because it's different, the implementation on JavaScript and C#. So in the case that you have a project on C# and for some reason decide to move to NodeJs or some kind of library, you need to rewrite all the conditions. Okay, let's look at an example. Here is a repository which contains all the source code. Let me show you the repository. Here is the repository which contains all the things related on this example. You will find the requirements and the structure and the technologies that I used. And here you have microservices, here, API catalog, and Sonar and Jenkins in the case that you want to check what happened in a pipeline. So I give you the entire context and or the entire scenario, so you can play what happened with these kind of things. So let's look the source code. Here is a simple project on Java, and I created some unit tests. Look, with some validations. Yep, everything looks fine. On the POM file, I need to do some kind of things to add support to the mutation test. So let me add the section of here, where is the plugins. I will need to add this kind of things. I will explain in detail. So this is Pitest, which have support to Gradle on Maven. And here I specify which is the format of the output of the result. You have the possibility to export on HTML, on XML. This is for a human readable format. And this one is in the case that you will export or push the results to Sonar, because Sonar have a specific plugin to have support to the mutation test. So if you use Sonar, you have like a quality gate which check a lot of things like the issues, the vulnerabilities, the code coverage, but don't check the mutation test. So if you add this plugin on Sonar, you can take the output of the execution of this mutation and send to Sonar. So here are the target classes related about, okay, which is or where is located my source code and where is located my unit test. I need to specify the version because I use as a variable. Let me put here. And let me show you something, which is the command to execute the mutation test. Yeah, I don't need to do anything else because this is all the things that I need to do. So I need to execute mevn clean package and the name of the goal of the mutation test. This takes some seconds. Okay, fail. And why this fail? And my face is like, oh, I wait this problem. Okay, this problem is related because by default, Pitest don't have support to JUnit 5. So to provide support, you need to go to the plugin and say, okay, I need to add the support to JUnit 5. And of course, I need to go here and put the name of the version. So with this modification here, adding this dependency, Pitest omit the default dependency. So if I execute again takes some minutes. No, some seconds. Look this. It's created 21 mutation tests. And here you have on the console, you have all the explanation about the different mutations that are used and the different scenarios, like the metrics. Okay, come on, this is not readable for us. This is a lot of things, a lot of information. You don't have some kind of format to help us. Well, here on the target folder, you have a new folder with the name PyReports. And if you go, you have this folder, which is the date of the execution. And inside you have two different files. First one, the HTML, and second one, the XML. Here are a lot of information that is usable only for the Sonar. And here you have the report. Let me go to this. Yeah, here. Here you have the report of the execution. So you have the number of classes, the mutation, and the strength, the effectiveness of my test. So if I go, imagine inside of, let me this. Here are all the code coverage, and you check this. Something is red. And I remove this line and that your test continue working. So here you have all the mutation and the results and the active mutation all the mutators that are using to check a specific scenario. And the same happened with the other classes. So, okay, great. But imagine that this is not so cool, because each time that you execute the mutation test, a new folder will appear. And now, perhaps it's a better idea that just one folder appear and represent the last execution. So I need to add this specific configuration and say, okay, don't add or don't create a new folder each time that you execute. So now all the results are inside of the Python report. This is especially useful when you want to push the results to Sonar or some kind of tool. Now, on this scenario, I analyze everything. So what happens if I want to exclude something? What happens if I want to exclude some specific classes? Like, let me exclude one specific class. This is like an array. So I want to exclude my documentation controller for some specific reason. Imagine that it's not relevant for me, and the information that exists inside of this class is irrelevant for us. So if I execute again, remember, this takes time. So the best things, or the best way to do, is start to exclude information, exclude the results. So let's go again. Wait a second. Okay, on the controller here now disappear. Look this, disappear the document controller. So you reduce the number of classes or the methods that you need to skip at some part. Another way to do, in the case that you want only exclude methods, not classes, instead, okay, a way to do it is this one. Exclude all the methods that have this name. And if I remove this, this mutator test will analyze all the source code and check or ignore this method. Imagine that you have too many methods related with the name to a string or with a specific interface, or you have many reasons. So in the case that you want only exclude methods, the methods across different classes, this is the best scenario, because you don't need to do this, like things like this. Let me show you. Imagine that you have the same method across different classes. So imagine this scenario. Imagine that you have 10 different classes. It's not the best scenario, right? The 10 different classes. So instead, you can do this. And it's more simple, because if someone add a new class with this method in particular, okay, I skip it. I don't need to add anything. Great. But this, you mentioned that this takes time. How can I skip the time that this execution takes? You can add like this particular command with history. So at some point, save the results of the previous execution, and the next time that you execute the same mutation test takes less time to execute it. So if I execute the first time, of course, will takes the entire time to execute it, but the next time we decrease. Here are the total time to execute, 11 seconds. So if I execute again, this time need to be changed a little. Imagine that I don't have too many tests. Look, 5 seconds. I reduce and a half the time of the execution. Of course, I have only, I think, more or less 12 or 20 tests, perhaps more or less. So it's a reduced scope of this kind of situation. Great. Everything looks fine now, and you have this this configuration. And there is one last thing that I want to mention. Remember that I mentioned that there are different kind of mutators, value, statement, and many others. And by default, Pitest use behind the scenes an engine to do this. And by default, use Gregor. Gregor do all the modifications. But there are other engines, like Descartes. And what is Descartes? Or what do Descartes? Instead to modify all the source code inside of a specific method, say, okay, what happened if I change the first line of the method and the last one? What happened if I instead to do the modification in an if-else condition? What happened if I only say, okay, always return an empty object? It's simple, because you don't have all the possible mutators to apply. And how this you can use it? Well, the first thing is, of course, add the dependency, and you need to specify here in the configuration which is the engine that you want to use. In this case, we want to use Descartes. And what happened if now I execute again the test without any kind of history? Of course, in this case, we'll cover different scenarios, not the same of our previous execution. Look, 15 mutation test instead to 21. So if I go to this report, just wait a second. Okay. And if I go here to the controller, remember that I remove a lot of things. Okay. Show me that remove all the instruction and my method continue surviving. It's a different approach of test. Of course, this is more specific to reduce the time of the execution. So to summarize my presentation, where you can use this mutation test, or on which industries are relevant. First one, you need to add, or it's a good idea, add support on the validators, adapters, or business logic, like the controllers, the service, the layers of your application that do relevant things. And where try to not use it on the DTO, on the entities, because only have setters and getters to set a value or return the value. It's not make sense. On the exceptions, don't have any kind of logic to validate. And on the external logic, libraries external to your application. Well, now, place to use it. Bank industries, crypto companies, medicals, institutions, planes, power stations, or Wall Street. All the situation or all the places where it's relevant for us that if something bad happened and the company lose money are relevant that you use mutation test. Of course, the best scenario is you add on every place mutator test, but perhaps you don't have time, you don't have the expertise. So in these industries are relevant And if you, for example, if you have a small company or a small application, perhaps mutation test is not an alternative. Some best practices: not run on every commit, because if you run this mutation test, increase the time of the execution on a pipeline. Imagine that takes more or less 15 seconds in a small application that have 20 tests. And imagine that what could happen if you have a small, biggest application with tons of unit tests and tons of classes. Send the results to an external tool like Sonar, because the report is great, but how many of us or you will check the result manually on a pipeline? No one. So the best alternative is push the results to Sonar. Okay, just validate or create mutation test for a specific part of your application. Again, don't use mutation test to validate if the test on a DTO or an entity or an exception makes sense. Limited the mutation, you can configure or limit the time of the execution of the mutation test or the number of mutators. Remember that I mentioned that Pitest or mutation test create a mutation, a different kind of mutation for a specific source code. So perhaps you can say, okay, for this method, only create me 5 different mutators or 10, what you want. Here is a possible improvement, but increase the use of resources. Instead to sequentially execute this mutator, I have this mutation, execute the unit test. I have this another mutator, execute the unit test. You can say, okay, I have these mutators or these mutations, please run in parallel the unit test. Of course, as you imagine, increase the use of CPU and memory, but it's a way to reduce the time of the execution of a mutation test. And last one, analyze the results, because this kind of tool could produce some false positive. So in some cases, when appear a false positive, you need to analyze what you want to do. Exclude the mutator, exclude the class or the method. So you have different kind of alternative. And at the end, here are some books related with testing. And some of them show you or give you possible examples about how create an effective test without the use of mutator test. And in the case of testing APIs, have a small part or a small section on the book that explain why it's important or why it's relevant use the mutator. And you have some blogs which give you a lot of information about different topics related with the test and the effectiveness of the test. This is the end. So if someone have some kind of doubts or question, it's the time to answer. If not, thank you for assist. Okay, we don't have questions. So thank you for assist. Thank you for listening and during this presentation.